Welcome to Unit 2, Lesson 26. This will be our last lesson before the test, which will be Thursday, November 30th. This lesson is titled Modeling with Systems of Inequalities in Two Variables. In today's lesson, we're going to focus on creating mathematical models using systems of inequalities. You have two learning targets for today. Number one, you should be able to interpret inequalities and graphs in a mathematical model. And number two, you should know how to choose variables, specify the constraints, and write inequalities to create a mathematical model. Our warm-up today is 26.1, titled A Solution to Which Inequalities? So this one says, is the ordered pair 5.430 a solution to all, some, or none of these inequalities? Be prepared to explain your reasoning. Remember that an ordered pair, the first number is your x, the second number is your y. So as we go through this, what we want to know, so x is greater than 0. Well, x would be 5.43. So if we say 5.43 is greater than 0, that is true. So it is a solution to the first one. Now we're looking at the second one. They want y. Y is the second number in our pair. So this would say that 0 is greater than 0. And that is not true because 0 is equal to 0. So it's not a solution to the second one. Now if we look at the third one, x is greater than or equal to 0. X in this case is 5.43. And that is greater than 0. So this one is true. It is a solution for the third one. And then this time we want y, which is 0, to be greater than or equal to 0. Well, in this case, that is true because it is equal to 0. So this ordered pair is a solution to the first, second, and third inequalities. If we were to graph the solutions to x is greater than 0, what would the region look like? Is the y-axis included in the solution region? So when we have a coordinate plane like this, our positive numbers go to the right, such as 1, 2, and 3, and our negative numbers go to the left, such as -1, -2, -3. So if I want numbers where x is greater than 0, I don't want to include x equals 0, which is the y-axis. So I would have a dashed line on the y-axis, and then I would end up shading everything to the right because I want numbers that are greater than 0. So we're saying everything to the right of the y-axis is a solution because that makes x greater than 0. Nothing on the y-axis is a solution because that would make it equal to 0. And nothing to the left of the y-axis is a solution because those values would all make x less than 0. What about the graph of the solutions to y is greater than 0? Is the x-axis included in the solution region? So if I only care about y values that are greater than 0, Once again, I would not include the line. So I would have a dashed line on the y-axis because I don't want y to equal 0. I only want y if it's greater than 0. So now we would shade everything above because these are my positive values, like 1, 2, 3, and so on. I would not include anything on the x-axis because that would make y equal to 0, and I don't want it to equal 0. And I don't shade anything below the x-axis because those are my negative values, and I don't want less than 0. I only want greater than 0. What about the graph of the solutions to the system x is greater than 0 and y is greater than 0? So now if we wanted to graph that, we would have our dotted line on the y-axis, and we would have our dotted line on the x-axis, and we would shade in everything in quadrant 1. This is where we're going to have positive values of x and positive values of y. That would be the area where both x and y would be greater than 0. We don't want the x or y axis because those would make x and y equal to 0. And we don't want anything in the other 3 quadrants because we would have x is less than 0 in quadrant 2. We would have x and y are less than 0 in quadrant 3. And we would have y is less than 0 in quadrant 4. So we would take all of the numbers in quadrant 1, not including the x or y axis. Our next activity is 26.2. This one is titled Custom Trail Mix. Take a moment to skim through the task statement. Be prepared to share one thing you notice and one thing you wonder. Next, use the table to write an expression to represent the total amount of fiber if you had A grams of almonds and B grams of raisins. What expression could you write to represent the total amount of sugar for the same amounts of almonds and raisins? Here's the nutrition information for some trail mix ingredients. We have peanuts, almonds, raisins, chocolate pieces, shredded coconut, sunflower seeds, dried cherries, and walnuts. We have calories per gram in kilocalories, protein per gram in grams, sugar per gram in grams, fat per gram in grams, and fiber per gram in grams. Tyler and Jada each designed their own custom trail mix using 2 of these ingredients. They wrote inequalities and created graphs to represent their constraints. We have Tyler on the left with his constraints and the graph that represents them. And we have Jada with her constraints and the graph that represents them. Use the inequalities and graphs to answer these questions about each student's trail mix. Be prepared to explain your reasoning. Number 1, which 2 ingredients did they choose? So we need to look. We have 4.76x plus 6.667y is less than or equal to 400. and we have 0.67x plus 0.07y is less than 30. So first, we want to look for ingredients where we would have 4.76 and 0.67. And I notice that when it comes to 0.76, I have that right here, representing the calories per gram of chocolate pieces. And I have my 0.67 right here, representing sugar. So we know that one of Tyler's has to be chocolate pieces. Now we're looking for 6.67 and 0.07. And we would find that 6.67 and 0.07, which is shredded coconut. So Tyler chose chocolate pieces and shredded coconut. Now we need to know what Jada chose. Jada has 0.14 and 0.61. I notice that combination right here with walnuts, 0.14 and 0.61. So we know that Jada chose walnuts. And we see a combination of 0.03 and 0. And that has two possibilities. That could be raisins, or that could be dried cherries. So we need to find something else that would tell us which one. If we look at the rest of the constraints, there's no more information that will allow us to pick which one it is. So we will say that it's walnuts and raisins or walnuts and dried cherries. Now, what do their variables represent? So for Tyler, this is going to represent the grams of chocolate pieces and grams of shredded coconut. And for Jada, it will represent the grams of walnuts and then the grams of either dried cherries or raisins. So for Tyler, X is grams of chocolate Y is grams of coconut, and for Jada, W is grams of walnuts, and Z is grams of raisins or cherries. What does each constraint mean? So if we look, they first both have x plus y is greater than 50 and w plus z is greater than 50. That means there are more than 50 total grams of ingredients. They both have ingredients being more than 0, so that means there are at least 2 ingredients, and both ingredients must be included. With Tyler, we said that Tyler looked at calories and Tyler looked at sugar. So there must be less than or equal to 400 kilocalories and less than 30 grams of sugar. Jada, on the other hand, looked at protein and fat. There must be more than 4 grams of protein and there must be less than or equal to 15 grams of fat. So that's what the constraints tell us. Which graph represents which constraint? So if we look, we can see x and y must be greater than 50. So that would be this dotted line right along here and the line shading. That would be right here, and all the line shading would be x plus y is greater than 50, and w plus z is greater than 50. Next, we've got must be less than or equal to 400. So if I had none of the x, then 6.67y less than or equal to 400. Y is less than or equal 400 divided by 6.67 is 59.97, so just about 60. We can see a point at 60 right here. And if we try it the opposite way, 4.76x less than or equal to 400, x would be less than or equal 400 divided by 4.76 is approximately 84. And we can see that point right here. So the solid black line right here and this really thin line shading below it is going to be the less than or equal to 400. Next, we have the 0.67x plus 0.07y is less than 30. So if we said no x, .30 divided by 0.07 equals 428. So that's going to be way up out of our screen. And if we did the opposite, and we said 0.67x less than 30, x would have to be less than 44.8. And we can see that right here. So the light blue shading and this line here is going to be this inequality. And then it just has to be in the first quadrant. So here we have the grams of ingredients. Here we have grams of sugar, no, calories. So that's calories. And this area right here is sugar. So if we want something that meets all of them for Tyler, we need something on this solid line or within this triple shaded area right here. So something inside this box here would make all of Tyler's the same. Now we're looking at Jada. Everything from this dotted line here up, so everything in this thin downward striped area is going to be the ingredients. If we're looking for the next one, which was protein, then W would need to be greater than 4 divided by 0.14, which is 28.6. And we can see that point right here. So this dotted line and all of this wider line shading to the right is going to be our protein. And then our last one here, W would need to be less than or equal to 15 divided by 0.61, which would be approximately 24.6. Which we can see at this point right here. So the solid line and the light blue shading is going to be the fat. So for them, if we want something that satisfies all of it, it needs to be in blue, it needs to have this wide shading, and it needs to have this thinner shading. So my solutions would be this solid line and anything in the double blue and line shading here. So anything in this area solves for Tyler. Anything in this triangle area here solves for Jada. Name one possible combinations of ingredients for their trail mix. So if we look here, we could say 20 grams and 40 grams would be right here in the middle of our solution area. So I'm going to say 20 grams of chocolate and 40 grams of coconut. Now for Jada's, we need something in this triangle area right here. So it looks like 20, we'll say 22 and 55. We'll put a point right there. And then we could say 22 grams of walnuts and 55 grams of raisins. Or cherries, since we don't know which one it is. The key is, in order for it to match, it must be in an area that is shaded by the light blue, the thick line, and the thin line shading. So in this triple shaded area in the first quadrant. Or for Jada, again, light blue shading, wider line shading, and thinner line shading. It needs to be in this triple shaded area or on the solid lines that create them. How did you know which ingredients each person used? We matched up the coefficient combinations to find an ingredient that had the same combination of numbers for their nutrition. The table shows the same values for some nutrients. How can you tell which one Taylor or Jada chose? We need them to match up in pairs. So we need the 4.76 and the 0.67 to occur on the same ingredient since they have the same variable. And we need the 6.67 and 0.07 to occur on the same ingredient. We also need those choices to end up in the same column. So these two both ended up in the calorie column, so that could create an inequality for calories. This one both showed up in the sugar column, and so we could write an inequality that represented the sugar content. So we needed them to match up being the same variable, and we needed them to match up being the same choice of nutrient. Why do you think Jada and Tyler both included the inequalities x is greater than 0 and y is greater than 0? Because we needed to have two ingredients. So you can't have 0 ingredients or negative ingredients and still be saying that you're using that ingredient in the trail mix. How do those inequalities affect the graph of the solution region? It limits us to region 1. It must be above the x-axis and to the right of the y-axis. Jada and Tyler each wrote 5 inequalities. Could all 5 form a single system? Yes, I treated them as a single system. What does it mean to have a system? All 5 solution regions match up and overlap each other. Our cooldown today is available on Kidam. It's 26.3, titled Design Your Own Trail Mix. It's time to design your own trail mix. Choose 2 ingredients that you like to eat. You can choose from the ingredients in the previous activity, or you can look up nutrition information for other ingredients. Think about the constraints for your trail mix. What do you want to be true about its calories, protein, sugar, fat, or fiber? Write inequalities to represent your constraints, then graph the inequalities. So we will go ahead and stay with 3 of the original. I'll say x plus y is greater than 50, meaning I want more than 50 grams of ingredients. And we'll say that x must be greater than 0 and y must be greater than 0 because I want both ingredients. Now I need to look at the ingredient list. There's peanuts, almonds, raisins, chocolate pieces, shredded coconut, sunflower seeds, dried cherries, and walnuts. I am going to choose peanuts and sunflower seeds. I like both of those, and I would want a trail mix that had a lot of protein. So I want to say 0.21 x. I'll make peanuts my x, and I'll make sunflower seeds my y. So we'll say x is peanut grams, and y is sunflower seeds grams. And so 0.21x plus 0.20y So they said they wanted more than 4 grams of protein. I'm going to say I want more than 5 grams of protein. If I look at the other ingredients, there's sugar, fat, and fiber or calories. So I am going to choose calories. So I would have 5.36x and 5.50y. So 5.36x plus 5.50y. And they said less than or equal to 400. I'm going to try for the same thing. So now down here, I have grams of peanuts. Along here, I'm going to have grams of seeds. And we'll try to label it the same way as the activity did. So they labeled by tens. So our origin will be 0, 10, 20, 30, 40, 50, 60, and we'll do the same thing on the y-axis. Now, must be greater than 50 combined would be a dashed line going from 50 on the seeds to 50 on the peanuts. And being more than, it needs to be up here in this region. I've limited myself to region 1 so that my x and my y are both greater than 0. Now I will change colors. Now if I go by my second, 0.21x plus 0.20y is greater than 5. That means that x would need to be greater than 5 divided by 0.21, which would be 23.8. And y would need to be greater than 5 divided by 0.2, which equals 25. So I would start at 25. I would end that line at 23.8. It would be a dashed line since I said only greater than. And it could be anywhere above this area as long as it's in this blue shaded area. So now I've got a double shaded area, which is red and blue, and that would satisfy total ingredients and protein. But I still need to graph the area that satisfies calories. So we're going to change colors again. I'll make it green. If I'm looking at calories, that's my 5.36x plus 5.50y is less than or equal to 400. So x would have to be less than or equal to 400 divided by 5.36, which is 74.62, which is out of my graph range here. So I'm going to make a quick adjustment. And instead of 400, we're going to say 300. Now, my x would need to be less than or equal to 300 divided by 5.36, which is 56. So my x would be at 56, so right about here. My y would need to be less than or equal to 300 divided by 5.5, which equals 54.5. So right about here. And because this is less than or equal to, then that's going to be a solid line connecting them. And because I want less than, it's going to be everything below and to the left. So in this green shaded area. So if I want a mixture that meets all 5 requirements, I need a point that is in this triple shaded strip right here or on the green solid line. Because now it's in the red shaded area solving the total ingredients. It's in the blue shaded area solving for the protein. And it's in the green shaded area solving for the calories. So we could pick any point in here. Looks like 30 grams of peanuts and 25 grams of seeds. Is it possible to make trail mix that meets all your constraints using your ingredients? Yes, I did make an adjustment to make sure that I could graph it on my graph, but I did have that strip of points where it satisfied all of my constraints. Write a possible combination of ingredients for your trail mix. We said it looked like 30 grams of peanuts and 25 grams of seeds. So if we wanted to double check, 30 plus 25 is 55. That is greater than 50, so we do have enough ingredients. Now we can check these two because 30 is greater than 0 and 25 is greater than 0, so we've met all 3 of these constraints. If I said 0.21 times 30 grams of peanuts, that's 6.3, and 0.2 times 25 grams of seeds is 5. So 6.3 plus 5 is 11.3. 11.3 is greater than 5. So it does solve for our protein. We have more than enough protein. And our last one is to check for calories. We have 5 0.36 times 30 equals 160.8. And we have 5.5 times 25 grams of seeds. That is 137.5. If I add those together, I get 298.3 calories, which does satisfy our last constraint. So we've been able to write the inequalities. We've been able to graph the inequalities. We have picked a point off of the graph that appeared to meet all of our inequalities, and then we checked it mathematically, and it did fulfill all of our constraints. So that is an answer to this one. You're free to do it however you want, but that's an example that works. For our glossary, we have two terms: solutions to a system of inequalities. All pairs of values that make the inequalities in a system true are solutions to the system. The solutions to a system of inequalities can be represented by the points in the region where the graphs of the two inequalities overlap. And system of inequalities: two or more inequalities that represent the constraints in the same situation form a system of inequalities. So if we go back and double check our learning targets for this lesson, number one, you should be able to interpret inequalities and graphs in a mathematical model. If you are comfortable with that, then you should be ready for the test on Thursday. If not, use this week to ask me questions. And learning target number two, you should know how to choose variables, specify the constraints, and write inequalities to create a mathematical model. If you are comfortable with that, you should be ready for the test on Thursday. If not, please use this week to ask questions.